Now, when you've drawn the least squares regression line, questions sometimes will actually want us to comment on the strength of the correlation. And in this case, you need to be very careful to always at least mention those two concepts. Whether, like in this case, if the value of R, is anything very close to 1, you see the value that is very, very close to the value 1, then you must mention that it is strong positive. Strong positive in that case, because the value of R you can see is very close to 1, which is 0.98, 0.98, a very, very close to 1. Then it means it is very strong positive, the value of R in that case. Now positive, and you realize that here the gradient of this line is actually a positive gradient. But you know that your teacher will explain this to you. When the line is a line that moves like this, then it means it will be, instead of positive, that relationship there will say it is a negative correlation. Depending, it is strong negative, moderate negative, weak negative, but it must be those two words which are mentioned, whether strong negative or strong positive. But in this line here, at least we agree that it is positive, because of course I normally say the gradient here is a -1 of a straight line, therefore it's a negative correlation, but that correlation is very, very strong. The association there is very, very strong because the points are very close to the line there, but that is determined by the value of R. So in this question here, normally on the scatter plot, very important, be sure about realizing that two sets of data demand of us now what? To match the two sets, and then we draw what? A scatter plot. We match the two sets, we draw a scatter plot. I'll repeat again what I said here. The first column here, 50 is matched with 12.9. So it means on your line here, 50, here's 50. Can you see that? 0, 10, 20, 30, 40, 50. 50 is matched with 12.9. There is 12.9. Can you see that? 50 matched up with 12.9. The second point, 70 is matched with 13.1. So you look at your horizontal line here, 70, there is 70, is matched with 13.1, 13.1. There we are. You see that? So you do the same with all other points on the scatter plot. Now, the related questions, like we said, that they'll want us to also discuss, find the least squares regression line. That it's an exercise that you can do with your teachers. You use a calculator to do that. Calculate the correlation coefficient, the value of R. I've just mentioned that value of R. Your teachers also will explain that to you, that the value of R, if it is very close, very, very close to 1, then we say it is strong positive. But if R from your calculator becomes a value which is very, very close to a -1, can you see now this value is very close to -1, then we say it is strong, but in this case it is negative correlation. As the question says there in the question paper, that calculate the correlation coefficient and comment on the strength of relationship. Comment on the strength. Whether strength is strong positive or strong negative, it depends on the value that you find for the correlation coefficient R. Is it very close to -1 or is it very close to a +1? Of course, your teachers, like we said, is -1 or it's 1. If it is 0, it means there's no correlation. It means in that case, we find that our points show no correlation at all. If the value of R is a value that is very, very close to 0, it means your points, when you draw them as a scatter plot, then they will give you no correlation at all. So it's either you go to a positive value, becomes moderate, strong positive, but it's positive in that case. When you go to a negative value, any value negative 0.1, negative 0.5, negative 0.7, or negative 0.8, then it becomes a negative relationship. Now you must determine whether it is moderate, whether it is weak, whether the relationship is a strong relationship towards a negative. Even this side, you must also indicate if it's a weak relationship, moderate one, a strong one, but in this case it is positive now. Negative if the value goes to -1, positive if the value goes to a +1. Right, I'm sure I've tried to explain very well what goes on with the scatter plot. Please be aware of that question. It is the first question in our exemplar paper. Work on that question with your teachers. Maybe I should also mention that, you know, in this scatter plot, in a case where you have a point that is very isolated, you see a point that is standing out there alone, this point is called an outlier. A point that is standing out there alone. Pardon me. As point standing out, when you plot the point, you realize that there's another point which is far from all the other points. You see here we have all the other points, but all of a sudden there's that point standing out there. It is an outlier. Now, when you look for the equation of the least squares of regression line, when you look for this equation, don't include the outlier. Do not, I write here, do not include the outlier when you actually look for the equation of the least squares regression line. When you're looking for the value of A, looking for the value of B from the calculator, and the value of R, the correlation coefficient, don't include that value which is far from the other point. It is an outlier. But if you don't have an outlier, it means you include all other points from the table there. You include all other points when you draw when you look for the equation of the least squares regression line, when you look for the value for the correlation coefficient, and also explain the relationship the relationship between the variables involved here, as well as explaining the correlation coefficient, whether it's strong or weak, positive or negative. Good.